Hello, good students. It's JD here. Today we're going to take a closer look at one of the interesting problems in calculus. Here is a problem that I've bumped with while other students were complaining a lot about this problem. So here is the problem. It's written here on the board. Given that y is equal to the square root of ln of sine x plus 1, find dy dx. How are we going to find dy dx in this case? For us to calculate the derivative of this function with respect to x, let's take a closer look. What exactly do we have at hand? Here is the solution. So y is equivalent to the square root of ln of sine x plus 1. Right, this is the same as y is equivalent to ln of sine x plus 1. Remember, mathematically, if we say the square root of a, mathematically this is the same as a to the power of half, right? So in this case, if we say the square root of ln of sine x plus 1, this is basically the same as this function to the power of half. But what do we know about functions of this form? We know very well that, let's take for example, we have say y is equivalent to f of x, right, say to the power of n. How exactly do we find dy dx? So y prime for this type of a function is equivalent to what? Is equivalent to, so what we have to do in this case, we bring down the power, right, which is basically n, then we multiply by the derivative of f of x. So the derivative of f of x here, we get this result. So after multiplying by the derivative of f of x, then we keep that function again, which is f of x, and we subtract 1 from the power. So that's how we differentiate functions of this form, whereby you have a certain function raised to a certain power. So like I said, you simply bring down the power, you multiply by the derivative of f of x, and you keep f of x as it is, and then you subtract 1 from the power. Are we going to use this same rule in this problem? Yes, we have to do that. So in this case, as we see here, we have a certain function raised to a certain power. The same way we have a certain function here raised to a certain power. So how are we going to differentiate this function? So the way we are going to do this is very simple and quite interesting. So our dy dx here is equivalent to what? So we're also going to bring down this power, which is 1 over 2. After bringing that power, we are going to multiply by the derivative of this function. So we need to look at the derivative of which function? Of ln of sine x plus 1, right? Times, we have to keep this function as it is, which is ln of sine x plus 1. Right? We have to keep this function as it is, but this time around we subtract 1 from the power, so it's going to be half minus 1. Quite interesting. So what are we going to do next? The next thing that we have to do, let's keep 1 over 2 as it is, and let's focus with this part. What is the derivative of ln of a certain function? Again, this is quite interesting. Remember, we know that the derivative, right, of ln of a certain function, the best way to differentiate a logarithmic function, or what we have to do, we are saying ln of a certain function, the natural logarithm of a certain function. So for us to find the derivative of the natural logarithm of a certain function, or what we have to do is to find the derivative of f of x, right? Once we have the derivative of f of x, then we divide by that f of x. Okay, so I hope and trust this is simple and straightforward. So what are we going to do next? The next thing that we are going to do, let's quickly use this idea that we have. So here we're looking at the derivative of ln of sine of x plus 1. So we need to find the derivative of sine of x plus 1 first. And the derivative of sine x, straight away it gives us cosine of x. And the derivative of 1, straight away it gives us 0. So there's no need for us to say plus 0. So straight away the derivative of this function gives us cosine of x divided by that function, which is sine x plus 1. Okay. This is quite interesting. So the derivative of this whole thing, it gives us this result. Times, so let's write this function as it is, which is ln of sine x, right, plus 1, right, to the power of what? What is 1 over 2 minus 1? We get minus 1 over 2. This is quite interesting. Then the next step, if we have to simplify this, we are going to get cosine of x divided by 2 sine of x plus 1 in brackets, right, and we are multiplying this by this result. What is this result? This is 1 over the square root of ln of sine x plus 1. Okay, so this is our solution. We can simplify this further and write it in a better, smarter format, which gives us the cosine of x divided by 2 times sine of x plus 1 times the square root of ln of sine x plus 1. This is our final solution. So yes, the derivative of this function with respect to x will give us this result. But you need to be very, very careful. There are two main principles that we've used to differentiate this. One of the fundamental theorems that we've used is to understand that if you are finding the derivative of a certain function raised to a certain power, all what we need to do is to make sure that we bring down that power, multiply by the derivative of f of x, keep f of x as it is, and then subtract 1 from the power. So straight away, this is the rule that we've applied here. We take this function, we bring down the power, we've calculated the derivative of this function, we have to keep this function as it is, and then subtract 1 from the power. And then after simplifying, we indeed see that this one is our final solution. This is very, very interesting. So if you have any problem, don't hesitate to contact me or bring the problem on the table, then we exercise together. Awesome.